Welcome to week 5 of our distance learning. This video is going to have a brief review of module 0407, exploring linear and exponential growth. Now that we are halfway through our distance learning, I hope that you guys have come up with a schedule and a routine for yourself, because even though this is not what life is going to look like forever, it is our temporary situation. So I hope you have been able to become acclimated and learn just how to survive and make it through this so we can still earn our credit. And then we will be very, very happy to all be back together in August. All right, this is the final lesson and quiz for Module 4. Next week, you guys will be moving on to a new topic. We are going to start our review with linear functions. Example 1. Beatrice is keeping track of the number of pages she reads over the summer. She started the summer off having already read 250 pages of her first book, and then she reads 300 pages each week. The function for her pages read is f of x equals 300x plus 250. What do f of x and x represent in Beatrice's situation? Whenever I come across a word problem, I always use the strategy of 3 reads. So that first read is what we just did. And that first read is just for an overview. When we do our second read, that is when I annotate the text. So I mark up the text. I circle, highlight, underline, anything that I think might be important. Also in that second read, when I'm annotating, is I'm looking for my question, because I need to know, what am I trying to answer? What is my end goal here? All right, let's begin read 2. Beatrice is keeping track of the number of pages she reads over the summer. She started the summer off having already read 250 pages of her first book. So I'm going to circle my number, but I'm also going to underline the words around it, because I need to know, what is that 250? Is it $250, 250 pigs? No, it's 250 pages of her first book. And then she read 300 pages each week. The function for her pages read is f of x is equal to 300x plus 250. What? What is a question word? So this is where it's going to tell me what I'm looking for. What do f of x and x represent in Beatrice's situation? All right, as part of my second read, once I'm done annotating, I'm going to go ahead and answer that question. So what do f of x and x represent? Well, let's start with f of x, because remember, f of x is telling me that not only it's in function notation, but that is just a fancy or the function way of saying y. So that's what f of x means algebraically. But now we want to know what it represents. What does it represent in this story? Well, right before my equation, it says the function for, so this is telling me what my function is for, her pages read. So that means this equation is going to tell me how many pages she has read. So therefore, that is what my f of x represents. Another part that could lead me to this answer, lead me to this discovery, is this initial sentence. It says she's keeping track of the number of pages she reads. So that's my overarching theme. So f of x in this scenario represents the total, because it's equal to everything else, number of pages read. All right, now let's answer the second half of the question and determine what our x represents. Well, when I look at my equation, I see that my x is being multiplied by 300. So I'm going to use that as my clue. That's my jumping off part. So I see that right here we have 300 pages each week. Well, 300 is the pages, so it can't be pages, and f of x was already pages. Well, it says 300 pages each week. Well, each is another word for multiplication or per. So therefore, week must be what my x represents. 300 times x. 300 pages each week. So x represents the number of weeks. Right. Now, if hopefully you guys were counting, but I only read through that twice, and I said I use a strategy of 3 reads. So my third and final read is to double check my work. I want to make sure that I still agree with my answers and that I did not miss answering part of the question. So what I've answered is f of x is the total number of pages read, x is the number of weeks. So Beatrice is keeping track of the number of pages she reads over the summer. She started the summer off having already read 250 pages of her first book and then read 300 pages each week. Yep, if I look at the equation, 300x. The function for her pages read is, f of x equals. All right, I agree with my answers. So now let's get to our question. What do f of x and x represent? I answered both of those, so check mark. We are good to go. All right, we're going to move on and do a second example of linear functions. Now I know this is a little bit different for those of you who are taking notes at home because you may not be writing the entire problem down. But one thing that you can be doing is writing down those strategies that I'm doing, writing down some keywords. And as we get into example 2, you're going to see that we do have to do some calculations. So there will be a little bit more that you can add to your note taking. Andrew had already sent 50 text messages this month, and each day he sends 11 more. His text messages are modeled by the function f of x equals 11x plus 50. What do f of x and x represent in Andrew's situation? How many text messages will Andrew have sent after 9 days? All right, first read is done, my overview. Now on to my second read, where I'm going to annotate the text and answer the questions. Andrew had already sent 50 text messages this month. Whew. And then each day he sends 11 more. So every day 11 more are sent. His text messages are modeled by the function f of x equals 11x plus 50. What, question word, do f of x and x represent in Andrew's situation? And then how, another question word, many text messages will Andrew have sent after 9 days? All right, I would encourage you all to pause the video at this point and on your own, try to answer both of these questions. So determine what your variables represent, and then find out how many text messages Andrew has after 9 days. All right, we are going to answer the first question first because we need to know what our variables are so that way I can find the answer to the second half. All right, f of x. Well, I'm going to look for those keywords before my equation because f of x is what is equal to everything. So it says his text messages are modeled by this. So f of x, so this equation, this function, represents his text messages. So f of x equals the total number of text messages sent. All right, now let's identify our x. Well, once again, I see x is being multiplied by something. It is 11 times x. So I'm going to find that 11 to help me determine what the x represents. And each day he sends 11 more. Well, 11 more of what? 11 more text messages. So 11 is text messages, so that can't be my x. And it says each day. So that's another way of saying every day, or 11 text messages per day. So therefore, day is my x value. So x is equal to the number of days. All right, that was answering my first question. Now that I know what my variables represent, I need to find how many text messages he sent after 9 days. Well, thanks to labeling my variable, I know 9 days is going to line up with my x value. Well, that's a funny arrow. Well, what do you think I can do to use this equation to solve for how many text messages he'll have at 9 days? I hope you said substitution. I can substitute 9 in for x. All right, f of 9, because x represents the number of days, is equal to 11 text messages each day, which in this case is 9. Oof. Plus the initial 50 cent. All right, when I look at my operations here, as always, I must follow order of operations. So I do see parentheses, but the parentheses in PEMDAS means a grouping symbol, and they're only around a single number. There isn't any hidden operation on the inside. So I don't really have the parenthesis grouping symbols. All right, E for exponents, nope, don't have any of those. MD, multiplication and division left to right. Ah, that's where my parentheses come in. It means multiplication. So 11 times 9 is 99 plus 50. And then the last step of order of operations, addition and subtraction left to right, I have addition. So F of 9 is equal to 149. All right, let's interpret our answer. What this means is f of 9, well, 9 is my x, so the number of days. So after 9 days, and then that's f of 9 is equal to 149. Well, remember f of x is the total number of text messages. So that means 149 is the total number of text messages. So after 9 days, Andrew sent a total of 149 text messages. All right, now for that third and final read, I'm going to make sure that I agree with my answers and that I didn't forget to answer anything. All right, so Andrew already sent 50 text messages this month, and each day he sends 11 more. His text messages are modeled by the function f of x equals 11x plus 50. Yep, text messages is f of x, days is x. All right, what do f of x and x represent? Answered that. How many text messages will Andrew have sent after 9 days? Yep, just answered that. All right, good to go. All right, we're going to move on to exponential functions. Example 3. James had been studying a type of mold that grows quickly. He has created the function f of x equals 200 times 1 and 20 hundredths raised to the power of x to model the number of mold spores per week. What does the 200 represent? And what does the 1 and 20 hundredths represent? All right, even though this is exponential, same strategy, 3 reads. James has been studying a type of mold that grows quickly. He has created this function to model the number of mold spores per week. So this represents the number of mold spores per week. So what, question word, does the 200 represent? A number instead of a variable. Oops, I should have cued in represent. And then what does the 1 and 20 hundredths represent? All right, I like this spin. Finding out what our numbers represent instead of our variables. Now, one thing that's going to help me with this is remembering the generic form of an exponential equation. The generic form of an exponential equation is f of x is equal to a times b raised to the power of x. When we reviewed this in one of the prior videos, we refreshed our memories that a is always our initial value. And when I graph, that means it's the y-intercept. Our b is our rate, our average. So b represents our rate. So when I know what the generic form looks like, that helps me discover what these numbers represent. All right, so 200 therefore must be my a value, all right, because that lines up with my example here. So 200 is my a, so I know it's the initial value, but if it's asking me what it represents, I need more than that. I need to know what it represents, what it means for the story. So mathematically, it's the y-intercept. But what it represents for the story, well, it says he's studying type of mold. He's studying the number of mold spores. Therefore, 200 represents the initial number of mold spores. It's kind of gross, but it does happen. All right, now B, well, we know mathematically B is our rate, but again, it says represent. So I want to know what it represents, what it means in the story. So 1 and 20 hundredths represents the rate of mold spores. Now we can be even more specific, because if we have 1 and 20 hundredths, well, that means, is it growth or decay? It's growth, because it is over 1, all right? Well, what's its growth factor? That would be the 20 hundredths. So it has a growth factor, 20, well, most of the time when we represent this, we represent it in terms of percentages. So that means our mold spores are growing at a rate of, well, 20 hundredths as the decimal version. If I convert that to a percent, that would be 20%. All right, let's do our third and final read to make sure we answered everything. James has been studying a type of mold that grows quickly. He has created the function f of x equals 200 times 1 in 20 hundredths to the raised to the power of x to model the number of mold spores per week. What does the 200 represent? Yep, I answered that. And what does the 1 in 20 hundredths represent? Yep, I answered that. Check, good to go. Example 4. Ooh, this one's a little less gross. All right, the value of a rare baseball card has increased in value each year since it was found at a garage sale. The value of the card is modeled by the function g of x equals 203 times 1 and 16 hundredths raised to the power of x. What does 203 represent? And then what will be the value of the baseball card after 5 years? All right, before I get to the second read, I would encourage everyone to pause this, and even if you can't physically underline or highlight, jot down and take some notes, jot down those key phrases, jot down the key pieces of information, and then go ahead and also try to answer the questions. That's a good way for you to practice on your own and see what you understand and what you still have questions on. All right, hopefully you guys just finished trying that on your own and now you have hit play. So we are in for our second read, our annotating and answering questions. So we are trying to find, so this is about the value of a rare baseball card, and it increases in value each year since it was found at a garage sale. The value of the card is modeled by this function. And I want to know what, so my question word, does the 203 represent? And then what, another question word, will be the value of the baseball card after 5 years? All right, let's start off with what the 203 represents. Well, if I'm talking value and it's a baseball card, that must mean money. So therefore, 203, well, that's where my variable A would be, and A is the initial amount. Well, if we're talking value, that means in this scenario, 203 is equal to the initial value or price of the baseball card. Geez, I can't type. And just for funsies, when I look at this, it looks like it's increasing in value, so that verifies that it's a growth factor because my rate is 1 in 1600ths. What is how much is it growing by? Hopefully you said 16%. All right, now my second question is, what is the value of the baseball card after 5 years? Well, I know I need to substitute, but what am I going to substitute in for? Because I never really identified my variables. Well, if we use those skills that we practiced a minute ago with linear functions, it says the value of the card is modeled by this function. So therefore, g of x represents the value. Well, in this question, what will the value be after 5 years? So 5 represents years. That must be my other variable. The E doesn't really look like an E, but whatevs. All right, so that means I can substitute 5 into my equation, and that will give me the value. So we have G of 5 is equal to our initial value of 203 times our rate of 1 in 1600ths, and that is raised to the power of 5 years. All right, order of operations. I need to start with my exponent, so please make sure when you calculate this, you remember that exponents means it's your base, so the 1 in 1600ths, multiplied by itself 5 times. So it's 1 in 1600ths times itself 5 times. That will result in a lengthy decimal. So for our purposes, I am going to use 3 decimal places. So go to the thousandth. So 2, actually no, because those are both zeros. I'm gonna go 1 more than that. And when we multiply by 203, that is our next step. So G of 5 is equal to 426 and 369 thousandths. Now, That's a fine answer. But if we look back at what things represent, we were trying to find the value, so money. Do we use 3 decimal places when we talk about money? No. So it's not acceptable for me to leave my answer like this. I need to round to the 100th spot. So I only have 2 decimal places. So to round, remember you look at the number after. So the 9 right here tells me whether I'm going to round up or down. And remember, if that value is above 5, you round up. If it's below 5, you round down. So that means G of 5 is equal to $426.37. So after 5 years, that's how much the baseball card is now worth. It's a pretty decent increase. All right, third read, let's make sure I agree with everything. So the value of the rare baseball card has increased. So it did go up. If it went down, I would have screwed something up. In value each year, since it was found at a garage sale, the value of the card is modeled by this function. What does the 203 represent? Yep, answered that. What will be the value of the baseball card after 5 years? Yep, answered that and rounded perfectly. All right, check. All right, example number 5. Which of the following exponential functions passes through the points 212 and 448? And then this one is multiple choice. We have 4 exponential equations here. All right, we have 2 methods of solving. All right, one method is just like we did in those previous examples. You guys could use substitution. Okay? And if that's your preferred method, let's look at our ordered pairs. Well, my 212, 2 is my x value, 12 is my y, or in this case, because it's function notation, my f of x. And then same over here, 4 would be my x value, 48 would be my f of x. So if you really like to use substitution, you can substitute those values into the equation and solve. So for example, for number 1, we would substitute, I'm going to focus on this one right here. So 12 would be substituted in for f of x. And then 2 would be substituted in for x. Okay? Let's go ahead and solve this one by substitution, because what we're trying to see is, does it make a true statement? Because if it works, that means your exponential function, when graphed, would go through those points. All right, well, 3 squared is 9. And then 2 times 9 is 18. Well, 12 is equal to 18. Is that a true statement? No, it's not. So that means A cannot be my answer. A is not the equation that matches. Now, if you get one of them that doesn't work, that means you don't even have to try your second point. Because if it doesn't work for one, it can't be the answer because it says and. It has to work for both. All right, that's one method that you can choose, is you can do substitution and go through all 4 of your options until you get the one that makes a true statement for both ordered pairs. Another option, since obviously we have technology, is we can use Desmos. We can graph the equations and then see if it passes through those ordered pairs. So that is what I'm going to switch to because we've already done a good amount of substitution practice. All right, so we're on Desmos. Let me scoot you this Word document over so we can see everything. Maybe. There we go. All right, now when you're on Desmos, please make sure you open up the little keyboard editor down here. All right, so we already checked the first one, so we know that one doesn't work, so we might as well go ahead and go down and check B. So f of x is equal to 2 times 3. Now see how we have an exponent of a negative x. I need to make sure I use and type it in as an exponent. Otherwise, just like it's doing right now, it's going to graph a linear equation, and it needs to graph that exponential curve. So this button right here where it says a to the power of b will put me up into exponent mode and allow me to type whatever exponent I want. Negative x. All right, well, there's my equation. So I'm going to first search for the 212 because that's a smaller point. That's a little bit easier. So we're going to have to scroll on here. So over 2 up 12. Well, that would be right here. At the 12, yeah, so does that work? Does this exponential function go through the ordered pair 212? It does not, because the ordered pair 212 would have been right here. I struggle with my 2's. Yikes. Wow, beautiful, thank you. All right, that one doesn't work, so we might as well clear it, and let's try the next one. Clear? Try again. So f of x is equal to 3 times 2 raised to the power of positive x this time. All right, now I'm already here. Oh, is it on 212? It is. That's a good sign. But because it says and right here, I need to make sure that it passes through both ordered pairs. So let's zoom out a little bit, drag it up, find that 48. All right, so 45, 46, 47, 48. And let's see, was it 4 on the x? Ah, right there, 4, 48. So this equation, option C, does go through both ordered pairs, right? So you guys have technology at your fingertips. So use it for good, not for academic dishonesty, but use it for good. So you can use substitution as a method of solving, or you can use graphing on Desmos as a method of solving. The choice is up to you. It's whatever works best. All right, before we move on to our final section where we're going to compare linear and exponential functions, I got a dad joke for you. All right, what music are balloons afraid of? Pop music. Dun, dun, dun. All right, lame joke out of the way, sorry. All right, comparing functions. Example 6, 2 separate bacteria populations grow each week and are represented by the functions a of x equals 3 times 2 and 1/10 raised to the power of x, and b of x is equal to 100 plus 4x. Which population will be larger in 5 weeks? All right, so first read done, second read, let's annotate. 2 separate bacteria populations grow each week and are represented by, so we have this function, which is E for exponential, and our second function, B, which is L for linear. Which, question word, population will be larger in 5 weeks? All right, so I'm going to compare. That means I'm going to have to solve both of these for 5 weeks so I can know whether my a of x function, which is my exponential function, is larger, or my b of x function, my linear function, is larger. Now, it says 2 separate bacteria populations grow each week. So that growth factor, that growing, is going to be my x, because I want to know the total population. So that's our a of x and our b of x. Okay. All right, now that we have marked everything up and identified our question, what our variables represent, we can use substitution to solve. So for our linear function, a of x equals 3, or sorry, linear, our exponential function, a of x is equal to 3 times the quantity of 2 1/10 raised to the power of x. So for 5 weeks, a of 5 is equal to 3 times 2 1/10 raised to the power of x. So in this case, 5 weeks. So order of operations, exponents come first. So 3 1/10 raised to the power of 5. That is 40. And I'm gonna go to the thousandth decimal place. So 841. Okay. Now in my calculator, I kept the entire thing on there and then just hit multiplying by 3 because it's always good to round at the very end. That helps limit and reduce your rounding errors. But because of how difficult it is to write on this, that's why I'm just going to write to the thousandth decimal place. So a of 5 is equal to 122 and then 523 thousandths. So what that means for our linear function, so for a of x, after 5 weeks, the bacteria has grown to 122 and 523 thousandths. And in this case, since we're talking about a bacteria population and it's really, really tiny, I'm going to keep all the decimal points. And also I want to make sure I have an exact answer, because if I'm trying to compare which one is greater, I don't want to, maybe it's only greater by that much. I want to wait until that comparison to round anything. All right, let's check out our linear one. Oopsies. All right, so b of x, so still 5 weeks, because we have to compare them at the exact same point in time. Otherwise, we'd be comparing apples to oranges. So b of 5 is equal to 100 plus 4 times 5. All right, start with our multiplication. 4 times 5 is 20. So 100 plus 20. So b of 5 is equal to 120. So in word form, for b of x, after 5 weeks, the bacteria has grown to 120. All right, so I have the information. But if I go back to that question, it wants to know which population is larger. So to all of this was the data I needed, but my actual answer is going to be the first equation, a of x. And how much, just as a bonus, how much larger is it? So a of x, is larger after 5 weeks by approximately how many more? 3 more if we round it up. So not much more. All right, let's do that third read to make sure I really answered it. 2 separate bacteria populations grow each week. So let's see, did they both grow from the initial value? For my red one, my exponential, my initial value is my a, so my 3. Yep, it went from 3 to 122, that definitely grew. And then for my blue one here, my linear, well, y equals mx plus b. Your B value, in this case, is your y-intercept, your starting point. So 100 is our initial value. Yep, it didn't grow quite as fast. It only went from 100 to 20, but it still grew. And then it wanted to know which population was larger in 5 weeks. That's what I have at the bottom. I officially answered that question. Function A will be larger. All right, guys, we have one more question left. You have been doing really good. Let's finish off strong so you guys can rock this 0407 quiz. All right, Theo plans to put $100 into a savings account. The possible accounts are represented by the functions f of x equals 5x plus 100 and g of x equals 100 times 1 and 400 raised to the power of x. Which account will have the highest value in 2 years? Which account will have the highest value in 20 years? All right, let's go for our second read. So he plans to put $100 into a savings account. And then we have 2 accounts. So this one, the first one, is that linear or exponential? Linear, yep. Then our second account, how about that one? Exponential. My variable is an exponent. E for exponential. So which account will have the highest value in 2 years? And then which account will have the highest value in 20 years? So we got 2 questions. We gotta do double comparison. All right, once again, before I can solve and do my substitution, I need to identify my variables so I know whether the 2 and 20 are gonna be substituted in for for x, or my f of x and g of x. Well, our equations, it says the possible accounts. So that means f of x and g of x must be our accounts. So f of x and g of x are the accounts. And well, what's in an account? Money, right? So that's our value, our money. And then 2 years and 20 years. So therefore, x is equal to the number of years. All right, so what am I going to substitute 2 and 20 in for? My x's or my y values? So my f of x and g of x. Yep, my x's. All right, let's start off with 2 years. So my first one here is my f of x, so we'll start there. So for our linear function, f of 2 is equal to 5 times 2 plus 100. So multiplication, 5 times 2 is 10 plus 100, 110. So after 2 years, that account will have $110. And let's see now how much my exponential account will have. So g of 2 is equal to 100. We're going to have to move this. Times 1 and 400 raised to the power of 2 years. So when I substitute that value in, I'm going to, on my calculator, when I did the math, I kept the entire decimal in there for accuracy. But when I write this, I'm just going to write 3 decimal points for ease, so to the thousandths. So 1 and the 400ths raised to the power of 2 is 1 and 0. There we go. When I multiply that by 100, we have $108. And if I round, because I know that I need hundredths for my decimal point, because I'm talking about money, 16 cents. All right, so which one's the winner? So after 2 years, which savings account is better? Yeah, my linear account. All right, so this one right here is better after 2 years because I have a little less than $2 more. All right, now let's see who will have the highest value in 20 years. Oopsies. So f of 20 equals 5 times 20 plus 100. All right, so 5 times 20 is 100. 100 plus 100 is 200. So after 20 years, this account will have $200. Let's check out the exponential one. G of 20 equals 100 times our growth factor. What is our growth factor? Yeah, 4%. All right, so 1 and 400ths raised to the power of 20 approximately as a decimal is 2 and 191 thousandths. When I multiply that by 100, I get G of 20 is equal to $219. And then if I round, 11 cents. All right, so after 20 years, which one has a highest value? It's a different one. So in this case, it is our exponential. So in the short term, 2 years, the linear one's better. But in the long term, the exponential one is better. All right, thank you guys for joining in. I hope these videos are proving to be helpful and make it seem a little bit more normal. But as always, after you watch the video, if you have any questions, and before you take the quiz for your 3rd time, please reach out to us. We would be more than happy to answer your questions or to have an additional Zoom with you, because sometimes being able to participate is what's needed for the learning factor. All right. Thanks for joining in. Keep working hard, guys. Bye.